just repeat this for everybody in the room. So basically what will happen is Jake will present. You'll have about 30 minutes present, and then we'll have 15 minutes of questions. Butler and I will ask questions first. Once we're done, we'll open it up to everybody that's on Zoom and in the classroom, anybody that wants to talk in. Well, that'll go on. We'll have at least 15 minutes scheduled. After that, everybody will exit, and then me and Butler will deliberate and then let Jake know his fate, as it may be. So if there is any problems or anything, I think everybody should be able to unmute themselves when they want to ask questions. If they can't, I'll figure out why that is. Otherwise, you can just put them in the text at that point. All right, Jake, turn it over to you.
Cool. Hello, everybody. My name is Jake Rowland, and my thesis was a Minecraft resource planning tool with cloud and learning management systems integration. We'll start with a quick overview, which was the project structure and frameworks, then the Minecraft Factory Planner, which was a web-based application for students. Finally, we'll go through some of the problems and solutions I face, as well as conclusions and the future research applications. So, the overview. We wanted to simplify Minecraft Education Edition into STEM C curriculum and integrate directly with learning management systems such as Canvas by developing pipelines and systems to seamlessly handle server instances, curriculum creation, and data sharing. This was broken up into two main portions. First was January 2020 through August 2020, which was the high-level architecture of the process, developing a data pipeline between both various systems, and we reached the proof of concept technology milestone. And then we had the second portion, which was between August 2020 and May 2021, where we developed a API as well as the web development for the Minecraft resource planning tool, and we reached the vertical slice milestone. So we heavily used AWS Cloud by getting all of the front-facing applications, which was the Minecraft Factory Planner, Canvas, and Minecraft, hooked up to the AWS Cloud through the use of AWS Lambda. AWS Lambda is a serverless architecture that essentially exposes endpoints for various applications to use. With those endpoints, we communicate with DynamoDB, which is a database system that is a NoSQL style database, and we store and receive data from AWS Lambda. Next, we also use Amazon S3 to contain a lot of the front-end HTML and CSS code that is cached using Amazon CloudFront that facilitates this loop here. The student or teacher would log into Canvas, and through the learning tools, interoperability, and OpenID2 Connect handshake, connect to the AWS Lambda and be authenticated on that server. From there, it will send a tool request to Amazon CloudFront, which is our caching server, and then that serves the Minecraft Factory Planner as well as various assignment data to be deployed natively inside Canvas to the students and teachers. Another various loop for the data is students and teachers can log into Minecraft, and they will associate their Minecraft account through AWS Lambda to their Canvas account. And then once it's associated, we start pushing up inventory and other data to AWS Lambda. And then the teacher can log in again through the OpenID2 Connect framework to connect to AWS Lambda and gather all of the students' inventories, as well as the students being able to view their individual inventory. The second portion was creating a Minecraft web-based application. This could better contextualize some of the learning standards that were difficult to contextualize directly in Minecraft, because we had full control of this application, as well as still preserving a direct communication between Minecraft. And the goal is to be used in tandem with Minecraft. This was built on top of Angular 10, which is a web design framework. That's one of the ones I was most familiar with, so that's why I chose that. As well as Ready.js, which is a node-based engine. I chose this one because some of the other visual scripting engines were more focused on visual coding, and this is more focused on visual graphic, as well as it working well with Angular 10. Finally, one of the last frameworks we used was Swimlane Ngx Charts. This is a graphing library to use for different graphing functionalities, and we used this because it had a good working system with Angular as well. So a little example assignment of how this application would be used. One of the potential solutions would be creating a model. You can model versus real world data. So originally you can create a model and you can give it a lot of different variables for what you think the real world data will represent, and then actually go into Minecraft, gather the data, use real world conceptual data, and then from there, you can then drag in the actual Minecraft node data that you collected and connect that up and then see how your estimates compare with real world data so you can quantify how well the model you created matches to the real world example. This also has the ability to promote reading of graphs. Graphs are not native in Minecraft, and we can use this application to have students learn to read and understand graphs while still being directly connected to what they are doing physically in Minecraft. So the editor Minecraft Factory Planner is broken up into 4 major parts. The first one is the editor, and this is the main focus for students, and it's an infinite grid workspace where the users can define and develop different factories that produce resources. Next, we have the block browser. It is a toolbar for the students. It contains all of the currently viable Minecraft items that are understood by the program, and as a drag and drop interface to drag these items into the tools. It also has sort and filter functionality. Next, we have the Minecraft browser. This is a direct connection to Minecraft and will update with the user's inventory if they've linked their accounts through one of the processes I mentioned earlier. We wanted to keep it fairly similar to the block browser, so blocks can be dragged from this inventory to the editor in the same fashion. Finally, we have the output window. This is split into 2 main portions, the focus view and the graph view. And this is to highlight specific nodes of importance so that users can monitor those individually. So drilling down into the Ready.js, which is the node-based editor, nodes are built up of 2 primary functions, the builder and the worker. The builder function essentially handles the layout of the node. That is the number of how many inputs and outputs that node accepts, as well as certain controls that that node accepts. The worker function, on the other hand, handles the day-to-day operations, like the update function. So anytime data changes, the worker function is called on that node, and it parses all of the inputs, the user information, and then passes that along to subsequent nodes. Next, we have controls. These are the user interface, how the user interacts with the nodes, aside from just dragging them and connecting them to each other. Next, we have sockets. These are the data highways. These define how nodes are related to each other and how they interact. They are typed, so nodes of different types cannot connect to each other unless explicitly defined. And this is really helpful for Minecraft. For recipes that require planks and logs, you can't connect wool because they are different types. So Ready.js editor is built on events, and nodes are just code that we write. Whenever you write a node, you have to register it with the editor, and certain events from the editor actually call the associated functions with those nodes. So the create node event calls the builder, which actually instantiates the node and creates all of the data associated with it. And then the process delete and connect sockets simply calls the worker node, the worker portion of the node that updates the data and passes it along the chain. There are some events that do not actually trigger any of the node lifecycle events, such as the transform node, which just changes the visual look of the editor without actually calling any of the node frameworks. So some of the extensions I built on top of the editor, these were built with the same builder worker paradigm. We have these supply nodes. They add data to the tree. We have the resource node, which is a user-defined rate node. So the user can actually edit the per hour rate that these items are being produced for a model. And then we have the Minecraft node, which actually takes real Minecraft data that has been calculated and collated and uses that as the data in there, and that is not user editable. Next, we have the crafter node. This is common. I would refer to this almost like a transformation node. It takes one kind of data, in this case, logs, and transforms it to use the planks. So it transforms the logs rate to the planks rate based on the crafting recipe of planks. Finally, we have the output node. This is the termination point for the trees. and there could be multiple termination points, but it defines the critical path of the node. So whichever resource takes up the most time to go through all the transformations, as well as using to aggregate a lot of the nodes for graphing features later on. Custom nodes. These are conceptually functions and large crafter nodes. So the traditional crafter would only be able to produce one output. Custom nodes, on the other hand, convert large input-output sequences into singular nodes with multiple inputs and multiple outputs. It does this by actually reducing all of the outputs to a set of linear equations based on those inputs. There is some user-defined metadata that is associated with each of these nodes. So whenever the user creates a node, they're able to give it a name as well as an icon and this share level. Those share levels are personal, group, and classroom, and they're currently stored on the backend. However, in the future, we want those to actually be used to share nodes between other students to create a collaborative work experience. So if I'm in the same group as another student and I mark my node as group level, that student would also be able to view my node that I created. So the block browser. We wanted to keep the style as same as the editor to improve the conveyance ability. And there's search and filter features for the students to more easily access certain items and features of the system. So custom nodes are also visible here. They are cached locally for quick creation in the Minecraft editor. And whenever we filter on custom node, we actually refresh that from the backend. So that counts as like the refresh button instead of constantly pinging the server over and over and over. The Minecraft browser, we want it to visually be identical to Minecraft in real world. So it's based on the real world Minecraft visual right here. And this is the actual in-editor visual. The items are in the same position. They have the same count. They have the same sprites. So, and the background is as close as we can make it. So all this data is based on real world Minecraft data that was gathered from the game. And we calculate rates of the game based on in-game item collection times. Originally, there was two formats. First, we would just take snapshots of the user's inventory every single second or however long we defined it, and pass all of that data to the front end and have the front end calculate, okay, when did I first see the item? When did I last see the item? What is the rate? I decided against that to instead move all of that calculation to the AWS backend, because AWS servers have a lot more processing power and capability, and that makes the data a lot easier to understand on the client side. So the output window, this is currently in the focused view, and this highlights specific nodes of the user's choosing. This data is updated as data changes in the editor view based on different either averages that the user places or updated Minecraft items. And you can actually step through the tree using the drop-down boxes to like follow specific paths through the editor. Next, we have the graph view focus. Graph view is limited to outputs only because that correlates all of the data and calculates all the items needed for the graph view. There are three separate graphs that are currently visible. The first is the line graph, which displays overall production of items over time, including surpluses. So if you're producing an item and not using all of it, that's included here. As well as the bar chart, which displays utilization of resources. So how efficiently is the process currently utilizing all the resources? Is there any resources that I'm overproducing and underutilizing? Finally, there is the pie chart, which displays ratios of production. This is like, of all the items that I produce, here are the ratios between these items. So there are some problems that I came into during the development of this. First was screenshots. Second was the database calls and asynchronous programming. Next was a feature with graphs that was not fully implemented. And finally, Canvas integration. So to start with screenshots, I used HTML to Canvas, which is a library that converts a HTML document to a downloadable PNG for submission as a grading purposes. There were some style constraints. However, those were less of a worry. There's two initial implementations that had major issues. The first one was paths would not be displayed between the nodes. And in the second implementation, user data inside the controls was not being displayed. Both of those are really key to grading because that shows the user's rates that they've selected as well as the pathways between that they've connected the nodes. So the solution or the issue is using foreign object rendering. So foreign object rendering converts unrecognized HTML stylings to an extended HTML format if the browser supports it, and it allows for a few things. Without using foreign object rendering, in the top image, you can see there's no connections between the nodes, and there's some styling issues, but all of the images were correctly displayed. With using foreign object rendering, the connections were being correctly displayed, but no images were being stored, which could be fixed with a workaround, but the more glaring issue was no rates were being saved. So the solution was to turn off foreign object rendering and actually figure out why these paths were not displaying. So the problem was the HTML path element was not fully contained within the SVG screen bound. So what does that mean? Every time we created a path, an HTML element called a div was created. That is essentially just a container that stores other HTML elements. As a child of one of those, so it inherits its parent, we have a SVG, a scalable vector graphics HTML element. Scalable vector graphics HTML elements can have multiple paths that define different visuals inside the SVG. As we see here, this is the path that defines the connection between the two nodes. In the combined view, you can see that the scalable vector graphics screen bounds in blue does not actually encapsulate the path's screen bound. And because we were not using foreign object rendering, the HTML to canvas would not render the path. The solution to this was whenever we were going to take a screenshot for all of the paths visible, we will transform the SVG to the correct location it would need to encapsulate that path. From there, however, because the path element is actually a child of the SVG, it would be transformed as well. So to mitigate that, we transform it back using the negative transform. And then from there, we were able to take a screenshot because now the path is encapsulated in the SVG's screen bounds. However, Ready.js, who created all these paths, does not actually like this format. So after the screenshot was taken and processed, you need to revert that process by transforming it all back and then retransforming the paths back to their original location. So next, we have the database calls. So initially, we wanted to have all of the items, custom nodes, and Minecraft items being stored on the backend and being updated. However, I realized really early on that specifically the item database, which has all the definitions for all the individual items, was not working well when it was hosted remotely. Partly because items are used heavily throughout the project, and I decided to transition that to a local item database. And what that means is that the items are actually served with the front end through CloudFront instead of being retrieved later on, and they actually exist at the time the application starts up. And one of the reasons behind this is items never dynamically change during usages, so planks would never have a different crafting recipe from when you start it to sometime because of something you did in the project. However, custom nodes and Minecraft items heavily benefit from this. Custom nodes have the ability to be shared between users in the future, and Minecraft items would continually be updated every second the user is in Minecraft. So we needed to make sure these were updated. I use a system called promises, which is essentially a code thing of, I will promise in the future values will be present at this location. So whenever we're doing like a database call or something that takes a lot of time to go across the web to a server, do some calculations, and come back, we don't want the application to stop and halt while we're waiting on that. So we use a promise to say, when I'm done and I get the data back, then we can update the visuals. But until now, just go and do what you're going to do. So it was originally implemented without promises, but I decided to transition to promises after backend functionality was fully implemented. So graphs. One of the issues with graphs is the legend actually does not contain all of the items currently visible on the graph. The reason behind that is we're using an open source graphing library called Ngx Charts, and there's currently a bug in the release version. Whenever you style the legend to be on the bottom of the graph, it is not actually included in the height calculation of the HTML element. This would cause uncontrolled scaling of the graph, and I had to use hard coding styles to reduce it. So graph 1 would be what it would look like without those hard-coded styles when the graph was first created. However, it's more nefarious than that. Anytime this was updated, because the legend was not included, it would always grow larger and larger and larger to the point where it would go off the screen and actually cut off the graphs below it and any other elements on that side of the screen. So yeah, I had to use a hard-coded system. So finally, we had canvas integration. We wanted to have the Minecraft Factory Planner be seamlessly integrated into Canvas so that if you were already on Canvas, you wouldn't need a secondary authentication process to access it. We decided to do this by passing up some user data to create sessions to the Minecraft application. However, we wanted to pass them through Learning Tools interoperability variables through the Canvas Developer Key portal. However, upon doing that, we noticed that the variables were not showing up or were not appearing on the back-end response where they were expected to be. So I had to deconstruct OpenID Connect. I talked to Canvas as well as Levi, the admin of Canvas here, as well as posting on the Canvas forum to determine what was wrong. It was finally discovered that it was actually being returned as a resulting JSON web token, and that by decoding that web token, we were able to retrieve the variables to pass them forward along to the web application. So that means now on Canvas, and if you launch it to the web from Canvas, you're already authenticated. You don't have to do any other authentication process, and you now have the same account on both the web version and on the Canvas version. So in conclusion, we were able to integrate Minecraft Education Edition with Learning Management System Canvas through the vertical slice development milestone, as well as developing enough features and connectivity to begin large-scale Dallas ISD testing and integration, as well as developing a prototype for future incursions into this gaming and learning space. Thank you. Any questions?
What's your goal? I just want to be clear on the languages and whatever else was used in this. So you had like, it seems some sort of web client thing, which was HTML and JavaScript, I guess.
Yes.
And using those libraries you mentioned. Did you have any custom code running on the server somewhere, or is that all the third-party tools only?
No, we did have, so for like I guess what do you mean, like custom server?
Like, did you have to write any server-side Java or any server code at all, or was it just a client connecting with database and
I did work a lot with on some of the backend implementation in the AWS Lambdas, and that's actually just writing JavaScript functions that are then acts as their own individual endpoints on the server. And I did have a hand in writing some of those for some of the functionalities like the Minecraft inventory and the custom nodes.
Okay, so I think at some point you mentioned putting calculations on the, or like moving calculations to the server. So that was done with this JavaScript. Sorry, what did you call it again? Right now?
AWS Lambda, and it's
Okay.
just it's just JavaScript that is then run on individual Docker clients on AWS.
Okay, all right. And that happens in response to client activity only?
Client or other backend activity, you
Okay.
can, yeah, basically they're just functions that I can call and they're associated with like a REST endpoint that we've defined.
Okay, and you said that at the end there that you were ready to begin large-scale Dallas integration or something like that. Is that actually started?
Well, it's not, it's in the works, I believe. We are going through cognitive walkthroughs right now with teachers, I believe, to get the assignment to figure out and like getting the verbiage and the wording for those.
Did you have this in the hands of any teachers prior to this to get feedback and testing on its usability, and did you find any problems?
Briefly, we did about a week ago. I think we had a somewhat of a cognitive walkthrough, and some of the things where some of the screens were smaller. So in the future, we need to work on a little bit more like reactive design for like smaller screens, as well as a little bit better Canvas integration. But that was some of the main issues, as well as just some of the things weren't completely obvious of like, oh, I can scroll in this box, and I can't scroll in this box.
Okay. I'm good.
What's your time budget for Q&A?
You got about 15 minutes.
Okay. First of all, what are the specific data you're collecting from Minecraft, and what are the triggers that cause that data to be collected? You mentioned just taking random samplings of their inventory. Was that? But then you said you were leaning away from that. Can you talk about exactly when does Minecraft log data with the system, and what data exactly is being logged, and is it any of it event triggered or just periodic?
So right now, in Minecraft, you log in and you do the first tutorial assignment, and then after that, you would start an assignment with a command. From that point on, I think every second we take a snapshot of the inventory, which is just a real basic slot index, item count at that index, and we pass that as a list up to the AWS backend. And then that's just stored and continually accumulated. And then from there, whenever we request the inventory on either the backend or the Minecraft web planner or on Canvas, I request that, and then it goes through and it accumulates all of those data points, and then goes through and figures out when did the item first appear, when did it last appear, what's the time step between those two items, and then what is the total between that to find the average, and then it just passes up at the very end. Here's the current inventory, and for all the items in the current inventory, here's the current averages for those.
I see. So it's all just passive pulse sampling observation. There's not, for example, there's not on craft. When something is crafted, then we say a craft has happened. We just observe the change in inventory.
Yes.
And can you give me an example of an assignment?
Yeah. So one of the assignments in Minecraft right now is we would want to, I guess in Minecraft or in just in general.
A teacher assignment that would use this system.
Okay. So yeah, one of them was you basically gathered some logs, and you want to figure out how many logs you need to gather in an hour to create 45 planks. Right.
That is the problem as opposed to the student.
That is the problem. So then you can go in either the Minecraft Factory Planner and then go in and figure out you can connect them all up to do the crafting system, and then you can start adding data inputs into the resource node of the logs to figure out if I get 4 logs an hour, I can craft 45 items, or do I need more? And then
But
from
that they can solve in the planner without even running Minecraft.
yes.
Okay.
But one of the other auxiliary things is, okay, now that you have a basic idea, go to these different biomes in Minecraft and then just start collecting wood. And from there you can see, hey, I can actually collect like 150 logs an hour in the forest biome, but I can collect 2 in the tundra. And then from there you can start actually associating which biome is better, and that's getting a little bit more of the larger scale of like thinking more critically about the differences in location or differences in like situation.
So like one of your examples with the planner was the bookshelf.
Yes.
So just talk me through the student would create the composition graph for here's all the chain of events that have to add up to a bookshelf.
Mm-hmm.
Is that correct?
Yes.
And then they would go in Minecraft and try to do that, and then we would observe the rates at which they're
You might give him some background of what the game is.
right. That's
Like what is
context.
Lumberjack Tycoon?
So we're going to be using Lumberjack Tycoon, which is basically a extension onto Minecraft. That's like you're given an order, and you need to fulfill that order to get money, to get money, to get items, to get collectibles, to build a bigger factory, right? So you'd be given an order of let's create beds, and one of the other people in the town's already gathering wool for you at this rate, right? So how many logs would you need to gather at a certain rate to create enough planks so that then you can combine those with the wool to make beds? So you can have the bed out, you can write out that whole thing. You already know because it's given to you how much wool is being created in an hour. And you can do that. And then you could add in the logs and figure out how many logs I need to do. And you could maybe input 50 an hour. And then you realize, oh, that is way too much by looking at the graph. You are heavily, you're heavily, basically.
I got it.
Got it.
So another question then, since I am kind of a little bit surprised on the indirect passive, just observing the inventory, because I feel like that we have the source code and we're injecting code, and we could make event notifications, this was crafted, whatever. How do you know that you're correctly inferring what happened just by looking at the inventory? For example, if I have a bunch of logs and I put them up into a chest, and then I have some wood planks and I pull them out of the chest, you're going to interpret that as I crafted the logs into the planks, but really I'm just moving stuff in and out of chests. How do you differentiate between what happened and what is observed?
So that's a lot of what we are doing. Is we don't actually do inferring of you've crafted these things into these things.
Okay.
We're just monitoring the resources of, hey, you now have planks in your inventory, and we know that you generated them in this amount of time. With your suggestion of I have logs and I take them out of my inventory and then I put planks in there, that would skew the data a little bit in the planks that I created really fast because I got a lot of them really quickly. But ideally, probably at some point in time, you had to actually craft those planks so that they would be in your inventory, and then you have a more realistic time frame over a longer average time frame of how quickly am I creating these resources? Because at some point they have to be generated somehow.
So it's single player only then, because my buddy could have put the
So
there.
I don't believe it's entirely determined yet if it's going to be completely single player, or if they're going to be instances, or if you're going to be like, you have a certain area of the world that you can build your factory, and there's someone else you can still communicate over like the chat or like through voice, but not actually like interact personally.
So,
And I'm not entirely sure.
so let me help you here. So, is there any limitation to what we can pull from pull from Minecraft? Are we limited in any way of what we
No.
pull out?
We're just using the inventories right now because it was simple to integrate.
Okay.
And also, we're not even storing that like the current, we're just storing like the time step that snapshot was taken. So we could transfer that to like stuff was crafted at this time step, stuff was transitioned to a box, out of a box at this time to a storage receptacle or something. And even that, we can also do like, where's the player position? How many blocks have they placed? What's their current durability of their tool? So it's just a lot of just extra stuff that we are able to gather. But currently, right now, we're just gathering the
So in future work, you may have quite a number of books in.
Yes.
For-
Yes.
And just because it wasn't his specific work, the Minecraft was done by another group specifically. We can actually inject into Minecraft too. We actually have a pipeline to spawn stuff and create things there, so we can go both routes.
Give you starting materials to work from.
Yeah, or spawn a template item, something like that. But that's like I said, that's out of the scope of his work because he was specifically he did work on some of that at the beginning in his first phase where he was a kind of a manager of a project. But the second phase, which is most of what he's presenting here, that was beyond the scope. Just getting the standalone EDU server functional, because that had never been done, it wasn't supported, was a feat.
Took about as long
Yeah,
as
sure. I think I'm good.
All right. Any questions from anybody on Zoom? Let's see. Oh, yes, we got one from Dr. Larson. Says expandability. How expandable is the system you created to support more than the recipes, the input and output in Minecraft? That is, what if a student wants to implement an algorithm or pipeline with the nodes, or use a visual language like Scratch? Perhaps something like a conditional statement at the diagram for selecting how to allocate a resource. What would need to change to support sort of like an algorithmic design?
Yeah, so to support that, all of the nodes that I demoed earlier, the Minecraft custom node and all that, that's all based on Ready.js, and Ready is an extremely extensible framework. It basically just defines, I have a node, it can communicate between other nodes, and it can have some form of user input. So there are actually, in other examples on the Ready.js, I believe, if statement nodes that you can have, where you can have 3 inputs of A or B, and then you connect the 2 A and B's out, and that allows you to actually pass data through. So that on its own is actually be very easy and extensible to do, because I did something similar with the custom nodes of that's all the custom nodes, the styling and the actual implementation is data driven by the data that's given to it on startup. So the number of inputs, outputs, all that is dynamically allocated. So for the like Minecraft item specifically, the only thing that would need to be extended is we need a larger subset of sprites to be used. But other than that, everything is data driven of this is the item ID, this is the name of it, this is the crafting recipe with the number of blocks, how much created, and all that. So if we have like mods that have like external items, we would just need those included in the sprite sheet. And then that can be then extended to have, say we want, I would say, yeah, say we wanted like a lumber mill in this case, of like it's just one block that like takes a bunch of planks, just rapidly does stuff to them, and maybe transforms them into chairs or something. And we can have that be a Minecraft item now visible in the Minecraft inventory or in the nodes.
So let me just pile on to that question. So let's say we want to build something like a logic system, right? So I want to build the logic system of a sorting system that's going into the lumber mill. Like I'm going to remove leaves and only let logs go in or something like that. So we could build a custom node, and as long as we define the kind of the linear equation in the middle, that which we could do through the custom node setup, it would automatically work with what you have right now, as long as we just give it the right icon and stuff like that.
Yes.
So if that was to be then shrunk down and we wanted to make it compatible with the leaf node at the beginning, and you wanted to combine that, say, into a custom node, would there be any problem with having a different type of linear equation? Like, is there any limitations to the equation so that whenever the custom node collapses down and it tries to build something, that would still work?
No. All of that is just, I created the own like format of these custom nodes, and it's basically here's the list of the inputs, here's the list of the outputs as they're based on the input rates, and we could definitely add something in there of like extra data that doesn't necessarily have to exist on all custom nodes, but only certain nodes. Like don't like filter out this many leaves, filter out this many planks, or filter out this many things, or like do some other like conditional logic that's added on top of the custom nodes themselves.
Okay, so right now your system only uses the idea of a rate, but if there was actually a logic or an equation in there, that wouldn't necessarily work, but we would just have to expand that system to say, maybe not just use a rate, but like a function pointer, like use this function pointer, which could be a rate, could be a logic, could be anything at that point.
Yes.
In other words, the only function you support right now is S times X, basically.
Yes.
Not like AX plus B or other more complex.
Yes.
Okay. Like, for example, you need at least this many of this, but then once you have those, this other thing is linear.
Yes, we could extend onto that by just like having like some base functions, and like input X uses the function like X plus B or whatever, right? And then input 2 uses X squared plus Z, and those are just like predefined functions, or like predefined like function like designs, not necessarily like actual functions, but just like the X squared and like the style of function. We could do that for like if statements also. Like if ID 6 is greater than 12, then you could use input 3, else you have to use input 2.
Right now it's limited to basically like balancing chemical equations. That's essential.
Awesome. Any more questions off of Zoom or in the class?
I have one last final question. So doing a web-based app with HTML and JavaScript versus writing a more traditional video game in standalone C++, which is more fun?
C++.
That is correct.
Yeah. Luckily, there's TypeScript, which helps a little bit with JavaScript. And there's a little cool things I could do with JavaScript, which is like really like not necessarily code smell, but like could get to that point. But yeah, I prefer C++ for JavaScript.
And Professor Larson says, great, we need this in a week. All right. Well, thank you all for coming. If you're on Zoom, I'll be starting the next one up here in probably about 10 minutes or so. Other than that, Squirrel, you can say to give feedback. Everybody else can take off.
Thank you.
I will see you in the next one.
Thanks, Jake.